Hey everyone, my name's Harry, and I'm excited to share this project with you on tubular flow cell scale-up. First off, a little bit about me. I'm studying mechanical engineering, and I'm set to graduate this upcoming May in 2025. My hometown is Houston, Texas, and some of my interests are Formula SAE, which I've done since freshman year, where I worked on the battery pack. Some of my hobbies include hiking, soccer, travel, and drones. On the bottom left there are two photos of me hiking in Utah and Switzerland. And then on the right is a photo of me at the PSG soccer game. The primary motivation of this research is to investigate and characterize a scaled up flow cell. On the right is a previous iteration of this flow cell design where it is comprised of an outer graphite electrode, and then on the inside is a Nafion membrane which houses the carbon microfiber bundle. The electrolyte, shown in green, flows in on the left around the Nafion membrane and then out the top, and the blue flows in through the Nafion membrane and then drains out on the left. And then there on the bottom right is one of the real versions of this render. One of the limitations of this design was that there were high ohmic losses due to length, and that it's also hard to scale due to its coaxial architecture.
One of the desired outcomes is to have an architectural change from coaxial to quasi-coaxial. As you can see on the diagram on the right, coaxial has an outer electrode with a Nafion membrane and then an inner electrode inside. This is like the previous iteration I showed on the last slide. This quasi-coaxial has four smaller electrodes surrounding a central one. Nafion was chosen to go on the four smaller electrodes to drive down cost, as a larger membrane would cost more. On the design on the left, you can see that the electrolyte flows in on the left through the four Nafion membranes and then out on the right. It has the opportunity to do an interchangeable cathode. So wires can just be slid in from the right, and different ones can be tested in the same flow cell.
The goal of this research is to characterize the performance of this unit cell and use this as a test bed to investigate other cathode options. One thing we would like to look at is tin because it has interesting passivation properties with V2 and V3. Also, a conductive polymer coating for the cathode, such as polyaniline, will be investigated as a protective layer. This would protect the electrode from corrosion while still allowing the reactants to pass through. This unit cell will inform decisions about future scale-up designs as it will serve as a modular, smaller representation of this quasi-coaxial geometry. On the top right are the 3D printed versions of this CAD, and those were done on one of the Formlabs 3D printers in the Invention Studio. And then to look at the bottom image, you can see the flow would come in on the left, where it's split into four Nafion membranes, and then flows out on the right. And then the other electrolyte flows through those top two quarter-inch barbed fittings. To reflect on my time in this lab so far, I joined at the beginning of this year last semester. The way I found out about it was through Dr. Liu's electrochemistry class, and I was super excited about battery technology and just wanted to get involved and learn more. It's been super cool to be able to apply some of the ME background that I have with design for manufacturing, also some of the prototyping with the 3D printing, but then also dive into the chemi side of things where I've really enjoyed learning about COMSOL and running some electrochemical and CFD coupled simulations to predict flow cell performance. On the top right there is a flow path with a static mixer on one of the previous design iterations of the flow cell that I showed earlier. And then below that shows the V4 plus concentration decreasing as the electrolyte flows through the static mixer. One of the other topics that I found super interesting is some of the different battery characterization techniques, which are polarization curves and cyclic voltammetry. Here's a final render of the quasi-coaxial flow cell. Thank you very much for listening to my presentation, and I'm looking forward to continuing researching this fall.